it up a little bit, you know? With a little, what about with a little honey on it? A little drizzle of honey on the peanut butter? Oh, yeah. Oh, yeah. Connor's here. And, okay. Yes, I did. And I already approved it. Here.
I'm sure because you
Yes, he's just here for fun. Okay, let's get started. Because we know 30 minutes goes by quick, you know? Oh, wait, I don't have the right screen up here. All right, so take a look at the top. We're going to fill out your find given when. Okay, so we're doing related rates today. So the F is what you're trying to find. G is what you're given. When, and then your equation. Now, typically, if it's an equation for like a cone or something that you might not like automatically know, they'll give it to you. Okay, but if it's like volume of a box or something, they're not going to give you that. Okay, then remember for these types of questions, because they're like real world scenarios, your derivative will be taken with respect to time. So you'll have to leave a ddt at the end of any letter that you use, whether it's a volume, radius, length, width, height, it doesn't matter. All right, so looking at that first question, okay, it says W, X, and Y are differentiable. Okay, all that means is you're allowed to take their derivatives. Okay, differentiable means you're allowed to take the derivative. Okay, then it says W equals X squared Y. Then it says X is decreasing at a constant rate of 1 unit per minute. Y is increasing at a constant rate of 4 units per minute. So let's plug some stuff into our find given when. I'm going to use this stuff at the top. Okay, so it says at what rate is W changing? What am I finding? dW dt. Okay, then I am given how fast Y and X are changing. It tells me X is decreasing at a rate of 1, then dx dt is -1. Y is increasing at a constant rate of 4, so dy dt is 4. Notice a negative for a decreasing quantity, a positive for an increasing quantity. Hey, Lama, the packet's right there. Oh. Okay, then for my whens, it says when X is 6 and Y is 20. And then the equation that they gave me is that W equals X squared Y. Okay, now keep in mind that any of your givens should be things that are always true. So it says that your X is decreasing at a constant rate of 1. That means it's always decreasing that fast. Versus when X is 6, X isn't always 6 because what's happening? It's decreasing 1 whatever per second. Okay? So let's take the derivative. For W equals X squared Y, what rule are you going to need to take the derivative of that? Product rule. Very good. So my U is going to be X squared. My V is going to be Y. What is U prime? 2x what? dx dt. Very good. Okay, for my V prime, it's the derivative of Y, which would be dy dt. And then remember that when I take the derivative, my W is going to go to a dW dt. And then for product rule, it'll be diagonal plus diagonal. So it'd be 2x dx dt times y plus x squared dy dt. Okay, then from here, you're just taking all those numbers that they gave you and plugging it in. Okay, so let's do it. 2x, remember regular x is a when, it was 6. dx dt is a -1, what was y? 20. Hey, have you seen Mark? He was in my second period, but he has not come back, sorry. Then my x squared is a 6, and my dy dt is a 4. Okay. So from there, if you have a calculator, go ahead and type that in. Okay, and then we're just looking for our answer. With how big those answer choices are, I feel like it's probably good. And then just tell me what you get. Yeah. Yeah. Michelle, who do you have? All right, what'd y'all get? Okay, negative 96, answer choice C, perfect. Okay, next one. Okay, it says an ice sculpture in the form of a sphere melts so that it maintains its spherical shape. The volume of the sphere is decreasing at a constant rate of 2 pi. Then it says at what rate in meters per hour is the radius changing? So find given when. What are they asking us to find? Okay, how fast the radius is changing, that is dr dt. Okay, and then they told us how fast the volume is decreasing. Now, they won't always say volume. Okay, if you're like filling up a tank, they could call it the amount of water, but remember, the amount of air in a balloon, that's volume. Amount of water in a tank, that's volume. Okay, but it does call it out here. So dv dt is a constant rate of 2 pi. And then it says when the radius is 5. Look over that. Any mistakes? Negative, because it's decreasing. Very good. Okay, then from there, we see that we have the equation given to us right here. Okay, so like I said, usually for spheres and cones, they're going to give it to you. Okay, for V, what's the derivative of that? dv dt. And then for 4/3 pi r cubed, I want to take the derivative. How many variables are in that equation? Only one, the r. Pi doesn't count, so I don't have to do product rule or anything fancy. R is the only letter. This is a regular power. So what's 3 times 4/3? 4. My pi is going to drop to an r squared. And then what do I attach at the end? dr dt. Very good. Then from there, we're ready to plug stuff in. Our dv dt is a negative 2 pi. 4 pi r is a 5. dr dt. So from there, we have negative 2 pi equals, what is 5 squared? 25 times 4. So that's 100 pi dr dt. Okay, then from there, if I'm trying to solve for dr dt, I'm going to divide that 100 pi across. What are we going to get for our answer here? Say it again. Negative 1/50, right? That is correct. Okay, technically that is the answer to this question. All right, second part of the same question. It says, at what rate is the surface area decreasing at the moment when the radius is 5? So same setup. So I'm not going to bother to change my find given when and all of that. Okay, the only thing I'm going to change is what I'm finding. I want to find how fast what's changing. The surface area. So my find is now a ds dt, everything else is the same. Okay, look for your surface area equation. Okay, do you see it up there right next to volume? Okay, surface area is 4 pi r squared. And I'm just going to steal that from this given right here. What's the derivative of s going to be called? ds dt. And then for the 4 pi r squared, remember, no product rule, just a regular power rule there, because I don't have any other letter besides r. What's the derivative going to be? 2 times 4 pi is 8 pi. R drops to a what? It was squared, now it's to the 1 and then dr dt. Okay, then from here, we're going to plug in our information. Okay, we know that our r from before is a 5. And then our drdt, we know from the previous question, is a 1/. So 8 pi times 5 would be 40 pi. And then it's divided by -50. So looking at your answer choices there, what would we want? 4 pi fifths. Now you'll notice, okay, that they didn't put the negative. Here's why that's okay. The question says, at what rate is it decreasing? So they're already acknowledging that it's negative by saying it's decreasing. They're just asking how fast it's decreasing. Okay. Good on that? All right, turn the page. Let's take a look at the water poured into the tank. Okay, notice this is the other type where they're going to give you the formulas because they're a little bit trickier to remember. Okay, fill out your find given when for part A. For the bottom one, yeah. So it says water is poured into a conical tank that's 24 feet tall and has a diameter at the top of 20 feet. The radius of the water surface in the tank is increasing at 0.75 feet per minute. At what rate is the area of the water surface changing when the radius is 4.2 feet? Okay, what are we trying to find? We'll say dAdt because we want the rate of change of the area. Okay, and then it gave me what? Well, what's the quantity? So let's call it drdt, but for surface, I get maybe picking an S. So I'm going to do drdt for the radius, and then it says it's increasing at 0.75 feet per minute. Then it says at what rate when the radius is 4. So let's put r equals 4.2. Okay. So looking at your available formulas, they've given you area and volume. Which one should we use here? Area, very good. So it tells me right here, area is pi r squared. Let's take the derivative. A goes to what? dAdt. And then for my pi r squared, 2 pi r what? d r dt, very good. Okay, then from there, we're just plugging stuff in. So my dAdt is going to equal 2 pi r, which is a 4.2, and then drdt, which is a 0.75. So let's go ahead and multiply that out. Okay, 2 pi times 4.2 times 0.75. Okay, that gives me 19.792. Okay, one thing, do not use 3.14 as a substitute for pi. You have to go to 3 decimals. So 3.14 is too short. It only goes to 2. So make sure you're using the actual pi button here. Okay, now real quick, since we've been kind of lazy on this, we're talking about area. So how would that be measured? Would it be feet per minute, square feet per minute, cubic feet per minute? Okay, for area, it would be feet squared per minute. Okay. All right, next question says, when the volume is increasing at 4 cubic feet per minute and the height of the water is 2, at what rate is the height of the water changing? So we're going to have to set up sort of a find given when that's a little bit different than before. So it says when the volume is increasing at 4, what would I call how fast the volume is increasing? Okay, dV/dt is 4. Also notice it does say increasing, that's why we're using a positive there. Okay, then it says the height of the water is 2. At what rate is the height of the water changing? That would be dH/dt. Okay, then I'm going to pull my volume equation, which it says is 1/3 pi r squared h. Okay, so we have a little bit of a problem here with our equation. How many letters do we have here? 2. We have an R and an H and they're multiplied. That means I'm gonna have to do product rule. Okay, unless there's a way for me to sub one of the letters out. So I know we haven't looked at this in a long time, but I want you to go back up to your cone picture. Okay, if I'm looking at this cone picture, they gave me how big the container is. How tall is the container? From here to here, it says, yeah, it's 24 feet tall. Okay, it also tells me the diameter is 20. What does that make the radius? 10. Now, what's going to happen is that as this container fills with water, okay, the water is going to match the shape of the container, right? So what's going to happen is you're going to end up with similar triangles. Okay, the water in the tank is going to make a triangle that is perfectly similar to the shape of the container, okay, this triangle. And so if you remember, what we're going to do is we're going to set up a proportion to eliminate a letter. So let's do R over H. R over H equals, keeping in mind that R and H are the radius and the height of the water based on how full it is. Okay, what will that equal on the big container? 10 over 24. And then in my equation, what am I wanting to know stuff about, R or H, for part B? Well, we're finding dH dt and we're given height, then we need to get rid of R, which means we're going to solve for R. So multiply your H over here. And I have that R is going to be equal to 5 over 12 H. And then I'm going to use that anywhere that I see an R so that my equation doesn't have R's in it anymore. It's going to be H's only. And then I don't need product rule. Okay. So let's come down to our equation. It was 1/3 pi R squared H. Now it's going to be 1/3 pi 5 over 12 H squared times H again. Okay, let's do our little numbers on that. 5 squared on the top is how many? 25. Times it by the 1 in the front, it's going to stay at 25. On bottom, I have a 12. What's 12 squared? 144. Times it by 3. That would be 432. And then pi H squared. Question mark? We're going to, but we're subbing first to get rid of the R. What should the total power be on H? 3. Because look, you have 2 in here plus 1 more. Yeah. So this is really an H cubed. And now that we've eliminated R, we're ready to take the derivative. So what is V going to go to? dV dt. Okay, in your calculator, we want 25 over 232, and we're going to times that by 3. So that would give me 75 over 232 pi H squared. Is that right? D H dt. Okay, and then from there, we're ready to plug stuff in. Our dV dt is a 4. 75 over 232 pi is going to stay. My H is going to be substituted with a 2. dH dt. I'm going to take my 75 over 232 and I'm going to times that by 4 because that's what 2 squared is. Okay, that gives me 4 equals 75 over 58 pi. And then how am I going to solve for dH dt if I'm trying to get rid of this fraction? To divide by this fraction, what is that the same as? Multiply its reciprocal across to solve. So I'll do 4 times and then I'm going to flip this. So it should be 58 over 75. And then turn that into a fraction. So it'd be 232 over 75. What am I missing? Okay, units, yes. What else am I missing? That
Good
top.
morning, Eagles.
And if the
Today's
pie was on the top,
I'm Sabina.
since I divided that
Here.
fraction across, now the pie. would
I pledge allegiance to the flag of the United States.
be- Okay, now let's talk about this is a height. So would I measure it in feet per minute, feet squared per minute, or feet cubed per minute?
Under the Texas flag, I pledge
Feet
allegiance
per minute.
to the Texas.
Okay, so remember that if it's a height,
One and
that would
indivisible.
be feet.
Now for a moment of silence.
Okay. Then turn back to that front page and let's put units on that bottom.
I'm an officer for DSU. Officer applications start this week. Go to D1.
For the first one, we were
These
doing
parents are invited to attend the annual
radius.
Career Prep Night
What
at
would your
1:30
radius
p.m.
have been measured in?
The event will take place in the library.
Would it be meters per minute, meters per minute,
Junior parents.
squared, or
Please
meters
remind your
cubed?
parents to check their email and submit.
For
questions
R, which
with
is
their
a
questions
radius.
answered during the meeting.
Meters
One
per
of the
hour.
different- Join the Build a Home Club in making. up
And
to
then for
5
this
for
second
life
question, it was surface area. What would that
hours
be?
per card, up to 5 hours total. Drop them
Meters
off in the
squared
library by
per
tomorrow.
hour.
Seniors,
Okay, so
don't
just
miss
keep in
the
mind, a
final
lot
call
of times on these questions,
tomorrow
it'll
at
say
7:10.
include
If you're
units in your
attending
answer.
UTA,
In that case, you would have to.
TWU,
Okay.
Dallas College, East Texas State, Western State, or UU Dallas County Promise, you must attend.
I don't really think we have time for one more.
A CSI and more. Check your email for the required RSVP form.
We'll knock one more out. Go
You're
ahead and
invited
turn to
to
number
our
7
side
right
of-
here.
At the Gallery show reception on May 9th from 6 to 8 p.m. We are just.
Okay, you're given a dy/dx. You're asked to find d squared y dx squared. What do we
The
do?
gallery will be open during the day if you would like to view.
Take the derivative.
School day.
So dy is gonna go to d squared y dx squared.
The RHS library is about.
Peeking at the other side, do we need product
If
rule,
you
quotient rule, chain rule?
The last day to do so is.
Or none of those?
Please remember to return
None.
all library.
Y
materials.
squared is gonna go to two
Well,
y
we have
dy
to
dx. And regular
Your
y is
baseball
gonna go
team
to
kicks off the
dy
playoffs tonight
dx.
at Grand Prairie High School. First
Okay,
pitch
then
is at
from
7
there,
p.m.
I want the second
Please do it
derivative
tomorrow
at
night
3.
at 7.
3 isn't enough for me to plug in. I need the whole ordered pair. Did they give it to me already?
1:30 p.m.
3,
Come
1.
on, support our
So
Eagles.
I'm gonna put d squared y
Happy today, Eagles.
dx
Go
squared
today.
at 3, 1. And now we're ready to plug in. Remember, for these types of questions, you gotta have the x and the y. Okay, my 1 is gonna go into that y spot. And then I notice that I don't have anything to plug in for the dy dx spots. What do I need to do to know what to put in that position? Plug back into the first one. Very good. So remember, I have the equation for dy dx. I just got to plug the numbers in. So if I did a 1 squared plus 1, what would I get for my dy dx? These are both 2's. So 2 times 2 is 4, plus 2 more would be 6. Okay. Good. Pull out your sheets and all. Good job. That's it.